Hello, and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of graphing exponential functions. This is standard A.9D in the great state of Texas, and we are using item number 27 of the 2021 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we've got a very simple question here, and if you know what you're looking for, you can probably go straight to the answer. But if not, that's what this video is for. We're looking for the y-intercept of this exponential function, g of x equals 73 times 4/5 to the x power. So let's break this down here. Our standard form of the exponential function is going to be y equals a times b to the x power. And when you look at the a and the b terms, they're very, very helpful in giving us an idea of what this graph is going to look like before we even plug it into the calculator. So what is this a term? Well, it could be many things. If we're dealing with investment, we're dealing with savings accounts and compound interest, it's going to be the principal. Right, that's the amount that you initially deposit. You don't make any additional deposits or withdrawals. Your interest compounds annually, and then you calculate how much money you have at the end of so many years. So that's another way to look at this, is that it is your starting or your initial amount. So sometimes we'll get problems that deal with population growth or bacterial growth, and something grows or decreases exponentially. There's always a starting amount, and that's what this a is. But for our purposes, we can also view a as the y-intercept, exactly what we are looking for. Now we know that a is the y-intercept because the y-intercept of any graph is where that particular function crosses the y-axis when x equals 0. Now let's think about what happens when x equals 0 in this standard form here. So y is going to equal a times b, and let me substitute 0 in for x. All right, so y equals a times b to the 0 when x is 0, but b to the 0, anything to the 0 is going to be simply 1. So a times 1, let's just simplify that b to the 0 to a times 1, and a times 1 is just the identity property, it's just a. So when x equals 0, y equals a. And that's exactly what we're needing. The y-intercept is, where is that function crossing the y-axis when x equals 0? So that's what we're looking for, that a. This b here is going to give us our rate. And so when we are greater than 1, it's going to be a growth rate. So if we graph it like this, right, it would kind of grow like this and move up towards the right. Our particular graph is not a growth rate, it is a decay rate because it's less than 1. Now it's not that much less than 1, it's 4/5, so it would decay kind of like this. It's going to start a little bit high and it's going to move down like that. So the growth rate means it's moving up to the right. The decay means it's moving down to the right. And then your x is simply going to be your step. So we don't necessarily have any context for this particular problem, but the step might be number of every week, every year, every month. A lot of times it is time-bound. So what is our y-intercept? Our y-intercept is our a term, which means our y-intercept is 73. So if you know what you're looking for, 73, it's sitting right there in broad daylight. So when we bubble this in, remember that we have a floating decimal point in Algebra 1. So that means you can really put it anywhere, but let's put it all the way over to the right. You don't mess with the positive or negative over on the left. By default, everything is going to be positive, so you can just leave it right there. Bubble in the 7 and the 3. And you are good to go. 73 is the y-intercept.